Okay, so this is more examples on adding and subtracting vectors using components. And as I mentioned even on the previous video, if you have any question, just either use the chat, or open your mic and then state your question. So when we are adding vectors using components, what we are doing is we are finding the horizontal and the vertical component of all the vectors that we are dealing with. So let's start now by stating that we have a vector A that is 120 kilometers per hour at 15 degrees south of west. Vector B that is 100 kilometers per hour at 32 degrees west of north. Vector C that is 93.0 kilometers per hour at 40 degrees west of south. Vector D that is 130 kilometers per hour at southeast. And then let's add here a vector D that is going due somewhere. Let's suppose that it's going 105 kilometers per hour and it's due west, let's say. Okay, we'll start by drawing those vectors into the specific in the axis. But before we do that, we will have to find the resultant. And when you see the expression find the resultant, that means that you are finding an equivalent vector to the vectors that you are working with. Understand? So if the resultant vector is A plus B minus C minus D, then you are finding an equivalent vector to A that is added to B, that D is subtracted from, and C is subtracted from. Okay? So in this case, what we will do is 1 over 2A minus 1 over 4B plus 2C minus 3D and plus E. So this is the expression that we have for the resultant formula. Now let's start with vector A. It's between south and west. Vector A is something like this. This is the representation of vector A with a magnitude of 120. And the angle with west is 15. Vector B is between west and north. And it is 100, oops. Let's make all the vectors red. 100 kilometers per hour. And the angle with north is 32 degrees. Vector C is between south and west. And it is 93 kilometers per hour. And the angle with south is 40 degrees. Vector D What is the angle with the either of those axes? I'm waiting for an answer here on the chat. Yes, it is 45. How do we know it? Because it's southeast. When you see this expression, that means that is right in the middle. Great. So now angle D or vector D will be between south and east. So south and east, and it is with a magnitude of 130 kilometers per hour. And one of the angles, doesn't really matter which one are you picking on this case. South, the angle with the south or the angle with east is 45 degrees. And then lastly is vector E that is due west. Okay, now let's start working with the expression that we have here too. So we said that what we will do is we will build a table that has 3 columns. On the first one, we will have the vectors that we are working with. So in this case, will be 1/2a minus 1/4b plus 2c minus d and e. And then on the second column, we will have the horizontal component. And then on the third column, we will have the vertical component. If you feel that you would want to make the verticals on the second column and the horizontal on the third column, feel free, doesn't really matter. Okay, so then what we have is 1/2a. And then we continue with negative 1/4b. And then it is 2c. We continue with negative 3d. And then the last one is just e. When we are done with all those, at the very last row, we write the resultant. Okay, so now we'll keep working on the horizontal component and the vertical component of each of those vectors. So the rule to find the horizontal component and the vertical component is build the right angle triangle, including the given angle. For A, will look something like this. This will give us 2 components, which are vectors. So this will be the horizontal component because it is along the horizontal axis. And this will be the vertical component because it is along the vertical axis. So now the horizontal, is it positive or negative? Is it going toward east or is it going toward west? Negative, good. So this is negative. And the vertical component, is it positive or is it negative? So is it going toward south or is it going toward north? It's negative, great. It's negative. And now we'll use the calculator. The horizontal component is adjacent, so it's related to the cosine ratio. So that means that, excuse me, that means that we will use the cosine in the right angle triangle. 120 times cosine 15. Please make sure that the calculator is on degree mode, and then we will go negative 1/4. Let's do this. Let's do this. what the formula is giving us. So 1 over 2 is what the formula is obligating us, multiplied by negative 116. I'm just rounding it to the whole number. The vertical component is the opposite of 15-degree angle. So then we will use sine. So in order to find the vertical component, we'll go 120 times sine 15, and we will have 31.1. 1 over 2 that the formula obligates us, times, we said that is negative 31.1. Are we okay up to this point? Now we'll move to the next vector, vector B. Again, we will go to the tip of the vector, and then we will create the right angle triangle that includes the given angle. This is creating the sides of the right angle triangle, and whatever side is going in the vertical axis, it's the vertical component, and whatever side of the right angle triangle is going in the horizontal is the horizontal component. Since the vertical component is going in the north axis, is considered to be positive, and since the vertical component is going in the west axis, is considered to be negative. Now, the vertical component is adjacent and the horizontal component is the opposite. In order to find the horizontal component, we will use sine. And now the magnitude of this is 100. So 100 times sine 32 will be 52 or 53. Negative 1 over 4 that the formula obligates us, the expression obligates us, times negative 53.0. Now the rounding here doesn't really matter too much, guys. Don't worry too much about this. And then the vertical component will be found by using cosine. So we'll go 100 times cosine 32, and we will have in our calculator 84.8. So on the table, we'll write whatever the formula obligates us, and in this case is negative 1 over 4, multiplied by, it's positive 84.8. We'll move to the next one. So the next one is vector C. Vector C has a magnitude of 93 kilometers per hour. So what we will do is we'll create the right angle triangle that includes the given angle. And the two sides are the horizontal and the vertical component of the vector. Whatever is going in the horizontal is the horizontal component. Whatever is going in the vertical is the vertical component. Both of those are negative because they are going in the south and west direction. So now in order to find the horizontal component, we will use sine because the horizontal is opposite of 40 degrees. So 93 times sine will be 59.8. The formula obligates us to have 2. So 2 times negative 59.8. And then the vertical component is the adjacent. So we'll be using cosine 93 times cosine 40. And this will be 2 times negative 71.2. I hope that this is clear. Now we'll move to the next vector, vector D, and we will have to create a right angle triangle including the given angle. This is the path that you will follow, guys. This creates two sides, and the sides that are in the horizontal direction are the horizontal components, and the sides that are in the vertical direction are the vertical component. The horizontal component is positive because it's going toward the east, and the vertical component is negative because it's going toward the south. In this case, since it is 45, we know that sine and cosine of 45 degrees is the same thing. The magnitude of this vector is 130, and then in order to find the component, we can use either sine or cosine. They are both the same thing. So 130 times sine 45, and we will have for the horizontal component -3 that the formula dictates us, multiplied by positive 91.9. And for the vertical component, -3 that the formula dictates us, the relationship dictates us, multiplied by -91.9. And vector E is that one of those special cases when we have either due east, south, north, or west. So the horizontal component is negative, whatever is the magnitude of this vector, that in this case is 105, and the vertical component is 0. Questions, concerns? In order to find the horizontal component of the resultant and the vertical component of the resultant, what we will do is we will add all of those components. So now in our calculator, 0.5 times -116, negative and negative for the -1/4 times -53 will be positive, plus 0.25 times 53 minus, because positive and negative will give you negative, 2 times 59.8. And again, negative and positive will give you negative, minus 3 times 91.9 minus 105. And it is negative 545.1 or nothing. You can leave it, doesn't matter. The same thing we will do for the vertical component. So 0.5 times -31.1. This is what it is. Negative and positive is negative. 0.25 times 84.8. Positive and negative gives you negative, so 2 times 71.2. Negative and negative gives you positive, plus 3 times 91.9 plus 0 will be positive 96.2. 56.55. I would prefer you to follow me with your calculator. So if there is something that is that I'm doing wrong or mistake, then please let me know. Those two numbers are the horizontal component and the vertical component of the resultant. So this is the horizontal component of the resultant, and this is the vertical component of the resultant. Now, what do is we take those two numbers and we plot them in the northeast southwest axis. So the horizontal component is negative. What does that mean? Is it going east or is it going west? West. Okay. So negative in the horizontal means west. I will draw it here. And negative in the horizontal means west. So we will see something like this. Okay, and now we have the vertical component. A positive vertical component means going north or going south. Yes, it means going north. A positive means going north. This is the same as X and Y axis. So when you are in doubt, is it going east or is it going west? Just attach into north, east, southwest axis, X and Y axis, and then see which one is positive and which one is negative. So this is the vertical component of the resultant. Now, using those two sides, we will create the rectangle, and then the diagonal that start at the same point as the two components are starting is the resultant. This is the resultant vector. This is that equivalent vector that substitute, let's say, replaces all those vectors, 1/4, 1/2, whatever we had as the expression. So the magnitude of this vector is the square root of whatever is this, 545.1 squared plus 96.55 squared. Now, you notice here that I'm ignoring the signs. Why? For two reasons. First of all, I know where the vector is. I know now that the vector is between west and north. So I don't worry about the sign. And the second is that when you are squaring up, a negative number still will be positive. So it doesn't really matter. Now in your calculator, you enter 545.1 squared plus 96.55 squared, and then you square root the whole thing. Then you should have something like 550, I will say 54, it's 53.58. So it's safe to say 554 kilometers per hour. But our job is not done here because we have to find the direction. When we are defining a vector, we do not stop at the magnitude unless the question is asking us only for the magnitude. But in order to fully describe a vector, you need to have the magnitude and the direction. And now the direction is you have some freedom here. So you can go with the angle that is with the horizontal axis, west axis, or you can go with the angle that is with the vertical axis or with north axis. Which one are you picking? Doesn't really matter. Both of them will be correct. So I'm calling one angle alpha and the other one angle beta. And I don't know, I'm picking angle beta today. So angle beta is inverse tangent of whatever is the opposite of it, which is the vertical component, so 96.55. And again, I'm ignoring the signs, or whatever is the adjacent, that is the horizontal component, 545.1. Again, guys, I'm ignoring the sign. And the reason is because I know where the vector is lying at. One more question that you may have is, why am I using tangent instead of either sine or cosine? You may use sine and cosine, but I always try to use the one that I possibly have less mistakes on. And when I'm finding the magnitude, I'm adding those two numbers to find the magnitude. So it's one more step to further find the angle. And if I have done a mistake on finding the magnitude of the resultant, then using sine and cosine, this will affect the result on using finding the angle. So I try to use the numbers of that possibly have less mistakes. You can, if you feel so confident on yourself that you have done everything right, then you can go ahead and use the cosine or sine ratio, inverse of it. So this angle, based on the calculations that I have, is 10 degrees. Since this angle, or this vector now, when I'm dealing with angle beta, is starting from west and going north, the resultant expression will be 554 kilometers per hour at 10 degrees. And I said it's going north starting from west. I want to see some good is north of west. Now you may say, what if I find angle alpha, or if you are looking for to write it in the reference to angle alpha, then the resultant will be 554 kilometers per hour at 80 degrees west of north. Both of them are right. You can look at both of the answers as the right answers.